Hi, IUP students. I'm Ajahn Chakapan Arampongpan. Today, I would like to present Chapter 11, Processing of Polymer Matrix Composites. This chapter is a part of this course 01 2063 311 Manufacturing Processes 1. So, in this chapter, I will present processing of polymer matrix composites, which consists of four main topics. First, overview of polymer matrix composite processing, PMC, that you see in the first line. PMC stands for Polymer Matrix Composites. The second topic is open mold processes, third closed mold processes, and fourth other PMC shaping processes. Next slide. Slide 2. Overview of PMC technology. PMC or polymer matrix composite is a composite material consisting of a polymer embedded with a reinforcing phase such as fibers or powders. So you can see that we call this material composite because we mix two material types, in this case a polymer and a reinforcing phase. PMC processes are important due to the growing use of PMCs, especially fiber reinforced polymers or FRP. So you can see here that if we add fibers into the polymer, this material particularly called fiber reinforced polymers, you can add either fiber or powders in the polymer, but in this case, if you focus on the fibers, you call that material fiber reinforced polymers or FRP. FRP composite right here can be designed with very high strength to weight and modulus to weight ratios. Why we get these ratios very high? Because the weight of this material still light, but we increase the strength of the composite material by adding fibers into the composite. So we get very high strength to weight ratio and modulus to weight ratios. So let's see the term modulus. I believe that you learn solid mechanics and you know Young modulus, or sometimes Young modulus also refer to stiffness. So this material, composite material, has very high strength to weight ratio and stiffness to weight ratio as well. And what is interesting about this material? FRP composites attractive in aircraft, cars, trucks, boats, and sports equipment. For example, if you want to reduce the weight, of the core, you can change from sheet metal to composite material. You can reduce the weight, and that means you can increase the performance of the car. Let's see another example, sport equipment. For example, badminton racket. You may see the racket of the badminton that made of carbon fiber. Carbon fibers or reinforcing phase that added into the material in order to increase the strength of the material. So when you have the racket that is light, you can hit very far longer than usual. Alright, so let's see next slide. Slide 3. PMC shape processing. Many PMC shaping processes are slow and labor intensive. This is disadvantage. Labor intensive. What does that mean? So usually we use many laborers do it manually. So the process are not very popular because of this advantage. In general, techniques for shaping composites are less efficient than for other materials, and these are the reasons. Composites are more complex than other materials. Need to orient the reinforcing phase in FRP or fiber reinforced polymer. And composite processing technologies have not been the object of refinement over as many years as processes for other materials. Alright, so for these three reasons, that's why PMC, polymer matrix composite processing, is not very popular, but the material itself is very interesting. Alright, let's go to next slide. This slide 4, explain about categories of FRP shaping processes. There are 5 categories of FRP shaping processes. First, open mode processes. You can tell from the term open mode. So in the first category, we use an open mode in the process. Second category is closed mode. The closed mode processes are similar to plastic molding, such as compression molding, transfer molding, and injection molding. These 3 molding processes use closed mode to form the shape of the part. The third category is filament winding. You know filament, right? Filament is continuous fiber. So you use continuous fiber or continuous filaments in order to make the part. Details of these categories will be explained later. The fourth category is protrusion. The term protrusion is similar to extrusion. Alright, you can see protrusion and extrusion. The difference is the first term, pol or X. I will explain the difference later, and we can use protrusion process to form polymer matrix composite material. And the last category is other categories, operations that are not in previous categories. Alright, so let's continue on slide 5. This slide shows classification of manufacturing processes for fiber reinforced polymer or FRP composites. So you can see here on the right hand side. We start from the left, which is FRP shaping processes. And these processes are classified into 2 main types. The first one, processes for continuous fiber PMC. And the second one is processes for short fiber PMC. So the main difference is the length of the fiber. The first one, continuous fiber, and the second one, short fibers. So let's see continuous fibers. For processes of continuous fibers, you can see there are 5 categories as shown in previous slide. That means you can use these 5 processes to form continuous fiber PMC. On the other hand, in short fiber PMCs, you can use only 1, 2, and 3. You can use only 3 processes to form short fiber PMCs. Alright, so again, The difference is the length of the fiber, continuous fiber and short fibers. For continuous fibers, you can use 5 processes, but for short fiber, you can use only 3 processes, 3 categories. Details of this will be explained in the following slide. Okay, so let's see slide 6. Starting material for PMCs. In a PMC, the starting materials are first a polymer and second a reinforcing phase. These two materials are processed separately. So you use one process to make a polymer and then you use another process to make reinforcing phase. So these two materials are processed separately before becoming phases in the composite. So we get into details of the first material, polymer. Sometimes we call polymer matrix. What does matrix mean? Matrix mean the main ingredient, the main material. So the main material is a polymer. And the polymer type that we use in polymer matrix composite include first thermosetting, second thermoplastic. However, we usually use thermosetting or TS polymers more than thermoplastic. So the principal thermosetting polymers, for example, or phenolic and polyester epoxy. Thermosetting polymers are the most common matrix materials. We use thermosetting much more than thermoplastic in composite material. You can see here in the last bullet here, you can also reinforce rubber by carbon black. Rubber with carbon black also polymer matrix composite. You can see the black tie of the core, why they look black, because the tie mix carbon black in order to reinforce the tie. So usually core ties are black because of carbon black. Okay, and they add carbon black in order to increase strength, increase mechanical property of the tie, rubber tie. All right, move on to next slide, slide 8, reinforcing phase. So this is the second material in polymer matrix composite, reinforcing phase or reinforcing agent. Possible materials for reinforcing phase include ceramics, metals, other polymers, or elements such as carbon or boron. I believe that you have heard the material called carbon fiber. So we can add carbon fiber into polymer to make polymer matrix composite. You can also use other materials such as metal or other polymers in order to increase strength of the material. So next point, let's see geometries. Geometries of reinforcing agent can be fibers, particles, and flakes. So in the previous slides, you may see the term fiber very often because we commonly use fibers as reinforcing phase. If you compare between fibers, particles, and flakes, you will see that we use fibers much more than particles and flakes as reinforcing phase. Alright, so in the last bullet here, of most enduring interest is the use of fibers as reinforcing phase in FRP. That's why we focus on FRP rather than particles and flakes. Alright, so because we use lots of fibers as reinforcing phase, so in next slide explain in details about fiber reinforcing phase. Common fiber material or glass, carbon and Kevlar. Okay, so you can use glass fiber to increase strength of the composite material. You can use carbon fiber to increase strength of the composite material, or you can use Kevlar. Some students may hear the word Kevlar. Kevlar is a polymer, is a type of polymer. You can add Kevlar fiber into polymers in order to increase the strength, and we can use Kevlar fiber to make bulletproof vest. Alright, bullet proof vest. You can use Kevlar fibers to make bulletproof vest. In Thai เสื้อเกราะกันกระสุน So because Kevlar fibers has very high strength, so you can use Kevlar fiber to add into another polymer and make the bulletproof vest. So it's very strong. Alright, so let's see next bullet. In some fabrication processes, the filaments are continuous, while in others, they are chopped into short length. So there are various forms, both continuous and short lengths. So in this slide 9, it talks about continuous form. So next we are going to learn about forms of continuous fibers. There are various forms. So start with continuous form. Individual filaments are usually available as roofing. So this is the first term, roofing. Roofings are collections of untwisted continuous strand, convenient form for handling. So when you see the word untwisted in Thai, un ก็คือไม่ twist ก็คือบิด so untwisted ก็คือคุณไม่ได้ถักไม่ได้บิด fibers. Alright, so rovings are collections of untwisted continuous strands, which is convenient form for handling. Alright, so the first form of fibers is called roofings. Let's see the second term. By contrast, a yarn is a twisted collection of filament. The difference is the term twisted and untwisted. Okay, so if you use untwisted continuous strand, that fibers are called roofings. If you use twisted continuous strand, this form is called yarn, the second form. Alright, let's continue. Slide 10, still about reinforcing phase. The third form is called cloth. The most familiar form of continuous fiber is a cloth, a fabric of woven yarn. Alright, and a woven roofing in the second bullet is similar to a cloth, but it consists of untwisted filaments rather than yarn. Okay, so in this slide there are two more terms of fiber forms. Compared to previous slide, since previous slide you have seen two terms, roofings and yarn. So if you use yarn to make a fabric, a piece, a sheet of fibers. If you use roofing to make a sheet, it's called woven roofing. If you use roofing to make a sheet, it's called woven roofing. But if you use yarn to make a sheet, it's called cloth. Okay. Use roofing to make a sheet is called woven roofing. Use a yarn to make a sheet, that sheet is called cloth. Alright, so from these two slides, slide 9 and slide 10, there are four forms of continuous fibers. Let's see slide 11. Slide 11 also talk about another forms of fibers. Fibers can also be in a mat form. A mat is a felt consisting of randomly oriented short fibers held loosely together with a binder. So when you read this sentence, you can tell that a mat is made of short fibers. A mat is made of short fibers instead of continuous fibers. So this is different form of fibers, short fibers. Mats are commercially available as blankets of various weight, thicknesses, and widths. Mats can be cut and shaped for use as preforms. Alright, sometimes they cut the mats and shape for simple form and call that simple form preforms. During molding, the resin impregnates the preform and then cures, thus yielding a fiber reinforced part. So once you have fibers both in continuous or short forms, you let the resin impregnate into the preform and then cure, make the material solidified and get a fiber reinforcement part. So this explains that once you get the preforms, you mold the preforms into the shape that you want and then let the resin impregnate into the preform and then cure, make it solidify and then get a fiber reinforced part. Alright, so let's continue on slide 12. Combining matrix, polymer matrix, right here. Combining matrix means combining polymer matrix and reinforcement such as fibers. There are two approaches to combine polymer matrix and fiber reinforcement. First, the starting materials arrive at the fabrication operation as separate entities and are combined into a composite during shaping. They are combined into the composite during shaping. Okay? For example, the process in this approach, filament winding and protrusion. Filament winding and protrusion use the first approach to form the shape of the part, and the reinforcing phase is continuous fibers. Let's see the second approach. In the second approach, the two component materials are combined into some starting form that is convenient for use in the shaping process. Okay, so for the second approach, the two component materials combine to get simple form such as a sheet form and then shaping the flat sheet, simple sheet form later in the process. Okay. For the second approach, there is two more terms, molding compounds and PrePET. All right, so let's see the meaning of molding compounds and PrePET. In slide 13, molding compounds. Molding compound from previous slide 12. Details of molding compounds are explained in slide 13. FRP composite molding compounds consist of the resin matrix. Resins represent polymer. Okay, so when you see the word resin, actually is a polymer. FRP composite molding compounds consist of the polymer matrix or resin matrix with short randomly dispersed fibers. So for molding compounds, we add short fibers into polymer matrix. Okay, this is short fibers, and this material form is called molding compounds. Most molding compounds for composite processing or thermosetting polymer. As I mentioned in the previous slide, the most common plastic is thermosetting plastic. And because they are designed for molding, they must be capable of flowing. Okay. They are not cured, and curing is done during and or after final shaping. Okay, so in this form, thermosetting have not been cured. Thermosetting polymers have not been solidified, but they wait for the process. In the processing, the thermosetting polymer then cure in the process. But in the initial, at the beginning, in this form, molding compounds, thermosetting polymers have not been cured. All right, so let's see an example of molding compounds. This example of molding compound is called sheet molding compound or SMC. SMC in polymer matrix composite material is a molding compound in a sheet form. So actually it's a sheet consists of short fibers and polymer matrix. So in this figure, you can see that the continuous roofing is cut into short length, short fibers, and then mixed into the resin here. The resin is put or loaded right here and then spread on the film, plastic film, and the chopper right here cut the continuous fibers, continuous roofing into short fibers, and then mix these short fibers into resin paste on the film, and then use various rolls in order to compress the mixture of resin short fibers to make a sheet form, and this sheet form is called sheet molding compound. All right, so we don't want to have solidification or curing of the resin in this process. We just make the simple form ready for process in the next step. All right, and this form is called sheet molding compound or SMC. Okay, let's see the other form. This refers to slide 12, PrePET. PrePET in slide 12 is explained in slide 15, PrePET. What the difference between PrePET and molding compounds? In PrePET, the fiber are impregnated with partially cured thermosetting resin to facilitate shape processing. The fibers are available as tape or cross-ply sheets or fabrics. Curing is completed during and or after shaping. So once you read this slide, can you tell me the difference between molding compound and PrePET? So in molding compounds, you use short fiber. In molding compound, you use short fiber. But in PrePET, you use continuous fibers, continuous filaments, rather than chopped random fibers. Alright, so the main difference is that PrePET are made of continuous filaments impregnated with partially cured thermosetting resins. Okay, so the difference is the form of the fiber. In this case, PrePET, they use continuous filament. Alright, so we finished about the materials in polymer matrix composites. Mainly there are two main materials, a polymer matrix and reinforcing phase. Alright, so we start the process. You know various forms of fibers, various forms of composite material. And then once we get the materials, we can form the materials by the following processes. Let's start with the first process. The first process is open mold processes. I believe you can tell the meaning of open mold. In Thai แม่พิมพ์เปิด Okay. Open mold processes are a family of FRP shaping processes that use a single positive or negative mold surface to produce laminated FRP structures. The keyword is right here, open mold. So these processes use a single mold, use the open molds. I will show you the figure of open mold in the following slides. Okay. The starting materials include resin or polymers, fibers, mats. You have seen the term mats before, right? Woven roofing. These starting materials are applied to the mold in layers, building up to the desired thickness. This is followed by curing and part removal. Curing is like make the composite solidified. Curing. Common resins are unsaturated polyesters and epoxies using fiberglass as a reinforcement. So they commonly use fiberglass as the reinforcement in the open mold processes. Alright, so you know general description of open mold processes. Let's see the details. Open mold FRP processes include first hand layup, spray up, and automated tape laying machines. Alright, so there are three sub-processes in this category, open mold processes. So let's start with the first sub-process in the open mold processes. You can see the code right here, 1.1. One on the right is the first process. One on the right is the first process of the first category. The first category is open mold. Alright, so I use this code to organize the process. So you will see the overview of the process classification. Okay, so 1.1 hand layup method. Hand layup method is the open mold shaping method, open mold, in which successive layers of resin and reinforcement are manually, not automatically, okay, manually applied to an open mold to build the laminated FRP composite structure. All right. Once you read this sentence, you can do by yourself manually. You don't need to use various complex machine, expensive machine. You can do this process manually by yourself. All right. So in the next bullet, that's why it's labor intensive. Use manpower to do this process, makes the part composite parts. Finish molding must usually be trim. Trim actually cut. So once you form the final shape of the part, you cut the excess material to get the finished product. Hand layup method is the oldest open mold method for FRP laminates, dating to 1940s when this was used for boat hulls. Okay, boat hull is like body of the boat. So hand layup is the oldest open mold. You can use manpower to do it manually, form the part manually. All right. So let's see this figure in slide 19. This explains how to do hand layup method. You can tell from the name of the process, hand layup. You use human hand to lay up the material, the composite sheet. Okay, so start with step 1. The mold is treated with mold release agent. So after finish your process, you can remove the part easily. So you apply the mold release agent as shown in figure 1. Figure 2, step 2, thin gel coat is applied to outside surface of the mold. So once you spray the mold release agent, you apply the gel coat. You apply the gel coat to easier and then get smooth surface. So you use gel coat in order to get smooth surface of the finished part. Okay. The first one use the mold release agent to remove the part easily, and then apply the gel coat in order to get smooth surface of the finished part. Alright, and then go to step 3. When gel coat has partially set, layers of resins and fiber mat or cloth are applied. Layers of resin and fiber mat or cloth. You have seen this term before, right? Mat, cloth, I apply. Each layer is rolled to impregnate the fiber with resins and remove the air. Alright, so it's called hand layup because you use human hand to apply the composite sheet and then use roller to get smooth surface and remove air. Okay, you can see roller here. It's like you put the sheet of composite on the mold surface, and this sheet already have the resin. So you put the composite sheet with resin, and then use roller to get smooth surface, remove the air. And once you get the desired thickness, you cure. Once you get the thickness that you want, you cure the thermoset by heating. Once you heat thermoset cure, solidified, and then you can remove the part. Okay. So let's continue on slide 20. Step 4 and step 5. In step 4, the part is cured. As I previously mentioned, once you get the thickness of the part that you want, you cure thermosetting polymer by heating. When you heat thermosetting polymer, you cure, you make it strong. And once you completely cure, you remove the part from the open mold. Alright, get the finished part and ready for trimming, cutting the excess material. Okay, so continue on slide 21. products made by hand layup. Let's see example products made by hand layup. Products are generally large in size but low in production quantities, and that is the disadvantage. Large but low in production quantities, not economical for high production. From the previous slide about steps in hand layup method, it takes quite long time to do, and it's not economical for high production, not suitable for industry that produce many parts. Okay, let's see applications. You can use hand layup method to make boat hulls, bodies of the boat, swimming pools, large container tanks, movie and stage props. The term props in Thai ก็เป็นพวกอุปกรณ์ประดับฉาก props. Okay. อุปกรณ์ที่ใช้ในการตกแต่งเวที alright, so you can use hand layup method to make stage props and other form sheets. Largest molding ever made was ship hulls for British Royal Navy, 85 meter long. Okay, so the part is very large, 85 meter long, and you can use hand layup method. Okay, let's continue on 1.2 in slide 22. 1.2, this is the second process of the open mold processes. The second process is called spray up method. You know the term spray, right? Spray. So you can guess from the name of the process that we will spray something in order to make the part. Okay, and let's see. In spray up method, liquid resin and chopped fibers are sprayed onto an open mold to build successive FRP laminations. Okay, that's why they call spray up method, because you spray liquid resin and chopped fibers onto the surface of the open mold. Attempt to mechanize applications of resin fiber layers and reduce layup time. Alright, so once you spray the materials, you can reduce the layup time, make it faster. So it's an alternative for step 3 in the hand layup procedure. So instead of using hand and roller, you can use device to spray the material and then make it faster. Products from this process are similar to hand layup: boat hulls, bathtubs, shower stalls, truck body parts, furniture, structural panels, and containers. Alright. However, because the products have randomly oriented short fibers, they are not as strong as those made by layup. Hand layup use longer fibers. Hand layup 1.1 use longer fibers. So when you use longer fibers, you get stronger part. But in spray up method, it use short fibers, so you get lower strength. Alright. Slide 23 show you a setup of spray up method. The process still use an open mold. Alright. The mold is an open mold, but they change from using hand layup, use hand to put the fiber sheet with resin, use hand to use layer. They replace that with the nozzle right here. Use a device to spray the liquid resin and spray the short fiber on the surface of the open mold. Alright, so you make the part faster compared to hand layup method. And then let's continue on 1.3, slide 24, automated tape laying machine. When you see the term automated is from automatic. Alright, so this type use automatic machine to make the composite part, and they call this process automated tape laying machines. Tape is the fiber sheet. So you can guess from the name of the process that they use machine to lay up the fiber sheets automatically. Okay. In this process, machines that operate by dispensing a PrePET tape fiber sheets onto an open mold following a program path. So you can program this machine. This machine will lay up the tape or fiber sheets automatically according to the program. Typical machines consist of overhead gantry. It's like the component of the robot. Overhead gantry to which the dispensing head is attached. So you also attach the dispensing head to the overhead gantry in order to lay up the tape fiber sheets. The gantry permits XYZ travel of the head, so you can control the layout of the fiber sheets by program this machine. Alright, let's see the photo of automated tape laying machine. The gantry is right here, and then you attach the dispensing head in order to dispense the fiber sheet on the open mold surface. Alright, this machine is operate automatically. Alright, so you know 3 processes in the first category, open mold processes. Let's continue in the next topic. Next topic in slide 26 is related to curing. You have seen the term curing before. This slide explains curing or solidification of thermosetting polymer. Curing is required of all thermosetting resin. If the resin is thermosetting resin, you need to cure thermosetting resin, make it strong. Used in FRP laminated composites. Curing cross-links the polymer. Cross-link, if you translate the term cross-link in Thai, เชื่อมขวาง it's like the molecule of the polymer cross-link and then get the network in the molecular scale. Curing cross-link the polymer, transforming it from its liquid or highly plastic state into a solid product. Okay, so once you cure thermosetting polymer, you get a solid product, strong product. Alright, there are 3 principal process parameters in curing. First, time, second, temperature, and third, pressure. So these 3 main process parameters affect the curing. Let me explain in next slide. In slide 27, curing at room temperature. You can do curing process at room temperature, but however it takes quite long time. Okay, so let's start with the first bullet. Curing normally occurs at room temperature for the thermoset resin used in hand layup and spray up procedure. You can cure thermosetting polymer at room temperature. Moldings made by these processes are often large. So you can see, because the part is very large, So it's easier to cure the thermosetting polymer at room temperature because the part is large and heating would be difficult. Okay, heating would be difficult to apply on really large parts, so they cure at the room temperature. In some cases, days are required before room temperature curing is complete. Okay, it takes quite long time because room temperature is relatively low. Let's continue to other curing methods. You can increase the temperatures higher than room temperatures by using an oven, infrared heating, or autoclave. Okay, you can use an oven in order to increase temperatures. You can use infrared heating used in application where it is impractical to place molding in an oven. Let's imagine the size of the oven. So if you have very large parts, you cannot put that very large part into an oven. So if that's the case, you need to use infrared heating instead. Alright, so infrared heating is easier for cure really large parts, for curing very large parts. And the last equipment is autoclave. Autoclave is an enclosed chamber equipped to apply heat and or pressure at controlled levels. Autoclave can control pressure as well. Autoclave can control both heat and pressure, while oven can control only temperatures. Oven cannot control pressure. Okay, so you can see here, if you use autoclave, you can control both temperature and pressure. And when you can control pressure, you can better increase the curing process. It's faster to cure thermosetting polymer. Alright, so you get an idea. If you want to get shorter curing time, you want to get faster, you increase the curing temperature. So once you increase the curing temperature, you can reduce the curing time. Okay. Alright, so let's move on to the second category, closed mold processes. I believe you know the meaning of closed mold. So in this category, they all use the closed mold in the process. Alright, let's see here. They are performed in molds consisting of two sections that open and close each molding cycle. Tooling cost is more than twice the cost of a comparable open mold. Okay, so if you compare between open mold and closed mold, the tooling cost of the closed mold is more than twice the cost of a comparable open mold. It's more expensive if you use closed mold. Alright, due to the more complex equipment required in these processes. Let's see, even though the tooling cost is more expensive, but there are some advantages of a closed mold, which are: first, good finish, smooth surface on all part surfaces. Second, higher production rates, get more products. And third, closer control over tolerances. You can better control the size of the part. And then the fourth advantage, more complex three-dimensional shapes are possible. You get more complex 3D when you use closed mold processes. Alright, so let's see classification in slide 30. Classification of closed mold processes. Okay, this is not open mold, this is closed mold. Classification of closed mold processes. There are three categories based on their counterparts in conventional plastic molding. So the process are similar to plastic molding. What does that mean? It means that you can use these three processes to form plastic material rather than composite material. When you study plastic processing, you also see these three processes: compression molding, transfer molding, and injection molding. So you can use these three processes to form both plastic material and composite material. They are the same processes, but the difference is the material. The material is pure polymer or composite material. Okay? So these are three processes in closed mold category. Alright, let's see 2.1 compression molding. So you can refer chapter 10 plastic processing. You can refer to chapter 10 plastic processing in order to understand compression molding. Let me summarize a little bit. Compression molding in Thai การอัดขึ้นรูป So you use two halves of the mold and then compress to form the material into the mold cavity shape. Alright, so you just change the material to composite material, but the process itself is the same as plastic processing. Alright, so I will not go into details because you already learned about plastic processing. You already learned about compression molding processes. Alright, 2.2 transfer molding. You can refer to chapter 10 plastic processing in order to get more details about transfer molding. You can use that transfer molding process in previous slide applied to Polymer Matrix composite. And 2.3 injection molding. This one also already explained in previous chapter 10. Alright, so let me summarize. There are three processes in the second category. First, compression molding. Second, transfer molding. And third, injection molding. These three processes are closed mold processes. They don't use open mold, they use closed mold to form the part shape. Alright, so let's continue. On the third category, filament winding. Okay, so filament is the continuous fiber. It's a fiber in a continuous form. And winding in Thai ก็คือการพันรอบๆ So once you know the meaning of winding, you can tell that we wrap the filaments onto the pattern, the mandrel, in order to make the part. Alright, so let's go into details. In filament winding, resin impregnated continuous fibers are wrapped around. The keyword is right here, wrap around, to represent the winding. Wrap around a rotating mandrel. A mandrel is like a pattern. A mandrel is a pattern that you want to make the shape of the part. Okay, so you wrap the resin impregnated continuous fibers around a rotating pattern, which is called mandrel. Wrap around a rotating mandrel that has the internal shape of the desired FRP product. Resin is then cured make it solidified, and the mandrel is removed at the end of the process. Fiber roofings, you have seen the term roofing before. Fiber roofings are pulled through a resin bath before being wound in a helical pattern around the mandrel. Okay. The operation is repeated to form additional layers, each having a crisscross pattern with the previous until the desired port thickness has been obtained. Alright, so you wrap around the condense fibers several times until you get the desired thickness. The thickness of the part tell you about the strength of the part. If you want to get stronger part, you get the thicker thickness. You get the more thickness of the part. The more thickness, the stronger part. Alright. Let's see slide 37, filament winding. And this is a setup of filament winding process. On the left hand side, you have continuous roofing, and then draw the roofing into the resin bath here. Resin impregnate into the roofings. Right now, resin impregnate into the roofing, and then you use the machine to wrap around the resin and fiber around the mandrel. Once you wrap around the mandrel several times until you get the desired thickness, you cure thermosetting resin and then remove the mandrel to get the part. Alright. So next slide 38, filament winding machine. This is the photography of the filament winding machine. The mandrel is right here, and then you use a machine to wrap around the filament with resin several times in crisscross patterns. You may ask why we need to do in crisscross pattern. Crisscross pattern is like you cross it in opposite direction. So if you do the crisscross pattern, you will get strong material in different direction, not just one direction. When you do the crisscross pattern, you can get the part with good property in all direction, in more than one direction. Okay. All right, so let's continue on slide 39, which is the fourth category. The fourth category is pultrusion processes. The term pultrusion is similar to extrusion, different between pol and X, and what that imply. In pultrusion, the workpiece is pulled. Okay, so you can see here why they call pultrusion, because the workpiece is pulled, not pushed. If you push, force the material to flow through the die opening, that process called extrusion. Extrusion push, force the material to flow through the die opening, but pultrusion pull the workpiece to flow through the die opening. Alright, so the difference is the action to move to flow the material. If you pull the material, the process is called pultrusion. Okay? Like extrusion, pultrusion produces continuous straight sections of constant cross-section. Pultrusion was developed around 1950 for making fishing rods. Okay, fishing rods. I guess you can tell this fishing rod ก็คือคันเบ็ดตกปลา in Thai คันเบ็ดตกปลา fishing rod. You can use pultrusion process to make fishing rods of glass fiber reinforced polymer or GFRP. GFRP stands for glass fiber reinforced polymer. Okay, so you can use glass fiber reinforced polymer to make fishing rods by this process, pultrusion. A related process called pole forming is used to make parts that are curved and which may have variation in cross-section throughout the length. Okay, so pole forming is related process. Once you get a straight cross-sectional part you want to make in a curved shape, you need to use pole forming after pultrusion to make the curve of the part. I will show you the process in the following slide. Alright, so I believe that you understand the general description of pultrusion. So let's see the details. In pultrusion, continuous fibrous roofings are dipped into a resin bath and pulled through a shaping die where the impregnated resin cures. The sections produced are reinforced throughout their length by continuous fibers. Like extrusion, the pieces have a constant cross-section. Okay, so the keywords right here, the work pieces have a constant cross-section because you pull the continuous fibers to flow through the die opening. So you will get a constant cross-section of the part, whose profile is determined by the shape of the die orifice. When I explain about extrusion in chapter 10, you will understand why you get constant cross-sections, and that cross-section shape of the die also determine the cross-sectional shape of the part. And the cure product is cut into long straight sections. Alright, let's see setup of the pultrusion process. You can see the filament right here. The filaments are dipped into a resin bath and then drawn into several dies. The first die is pre-die former, and then go into die, and then go into pull rollers. So at this point the resin is cured. The resin is cured, becomes solid part, and then you cut into the length that you want. Okay, so you can tell that the cross-sectional shape of the part from pultrusion process has constant cross-section. They have the same constant cross-section all along the length of the filament. Okay, and this is pultrusion process. It used to make fishing rods. Let's see materials and products in pultrusion. So right now we on slide 42. Materials and products in pultrusion. Common resins include unsaturated polyester, epoxies, and silicones. They are all thermosetting polymers. Alright, as I mentioned earlier, the Polymer Matrix commonly use the thermosetting polymers. Reinforcing phase include E-glass, which is the most widely used. E is a type of glass fiber. It's like grade E, and so you add grade E glass fiber into the polymer and then get the composite part. Grade E glass fiber is most widely used in this process in the proportions from 30% to 70%. The products from this process include solid rods, tubing, long flat sheets, structural sections such as channels, angle and flange beams, tool handles for high voltage work, and third rail cover for subways. So you can see here that the products has the constant cross section such as rods or rails. Alright, so once you get the part form protrusion, you will get straight constant cross-sectional parts. And if you want to make the part in a curved shape, you need to use pole forming. Okay, pole forming is additional steps to form the length into semicircular contour, curved shape, and alter the cross-section at one or more locations along the length. Alright, from this sentence, you want to make the part into a curved shape, semicircular shape. Protrusion is limited to straight sections of constant cross-section, right? So you use protrusion to satisfy the needs for long parts with continuous fibers reinforcement that are curved rather than straight. Alright, so let's see pole forming process. So once you use protrusion to make a straight constant cross-sectional part, you use this mold shape and die shoe in order to make the part in the contour shape, in the curve shape, not straight cross sections. Alright, and this process is called pole forming. Alright, let's continue. The last category is other PMC shaping processes. Other means rather than the first four processes, rather than open mold, rather than close mold, rather than filament winding, rather than protrusion. This is other shaping processes. These other may be centrifugal casting, tube rolling, continuous laminating, cutting of FRPs, and in addition, many traditional thermoplastic shaping processes, such as blow molding, thermoforming. Okay, so you can see that these processes are not included in the previous categories, are not included in the previous four categories. Okay, so they categorize in the fifth category. Let's see one processes in this category, tube rolling. So you roll the composite sheet into a tube. You want to make a tube, and then you make the tube by roll the composite sheets. Okay, you can see the side view here in figure A. You roll the PrePET sheet into a tube and then use a mandrel, which is a pattern, to control the diameter, inside diameter of the tube, and then you get a tube as shown in figure B, and this process is called tube rolling. Alright, so after you get the parts from all categories, all five categories, there is one additional step after the processes. This additional step is cutting method. This slide explains about cutting methods. Cutting methods for uncure. So right now, in this slide, you will see the process to cut the uncure, not strong FRP. Okay, the thermosetting polymer in the composite has not been cured. Okay, so the strength is not very high. You can cut the uncured material by using knife, scissor, power shears, steel rule blanking dies to cut uncured material. Okay. The strength is not very high, not very strong part. Or you can use non-traditional methods such as laser beam cutting and water jet cutting to cut uncured FRP. On the other hand, if the thermosetting polymer has been killed. So the strength of the part right now is very high, strong part, because thermosetting polymer already killed. And the cutting method for kill FRP, you can use cemented carbide cutting tool, you can use high-speed steel saw blades. For some advanced composites such as boron epoxy, you can use diamond cutting tools to cut kill FRP. You can also use water jet cutting to reduce dust and noise problems. Alright, you can see here that the kill FRP are tough, abrasive, and difficult to cut. So you need to use strong cutting tool materials such as cemented carbide in order to cut kill FRP. Alright, so I cover all content in chapter 11, processing for polymer metal composite materials. So if you have questions about this lecture, you can email me. I will give you my email. In case you have questions about this lecture, you can email me at fengchar, FENGCHAR @ku.ac.th. I am Ajahn Jack. Feel free to email me with your questions. Alright, good luck on your midterm exam. Thank you.